Hello and welcome to Universe Sandbox 2. So I have a suggestion here asking, can you make Earth the size of the observable universe by locking the mass and making the radius huge? With, what is that? 8 exclamation points. So he really wants me to do this. So now let's go ahead and lock the mass. And where should we start? Okay, well, that's no longer much of an Earth. And it's evaporating. Very quickly, in fact. Let's go ahead and halt time. Can't even select it. Oh, wait, I had it for a moment there. Let's go ahead and just go to powers. Let's see. Would that be under tools? It's no longer called powers. Interesting. Let's go ahead and delete particles and dust. Now it gets like the planet, no problem. So now it's equivalent to 32 moons. Let's go ahead and just ensure that stays one massive Earth. Not very Earth-looking anymore. But it's now the diameter of 1.8 Milky Ways, so something closer to Andromeda than it is to Milky Way. Go ahead and place a galaxy right next to it. All these galaxies are basically the same, so it doesn't really matter which one I place, so let's go ahead and put Andromeda next to it. There we go. So now we have a galaxy to kind of compare. And as you can tell, it is probably bigger. So let's go ahead and remove that. And let's continue. Now, after just a quick little Wikipedia expedition, I am seeing that the observable universe is 8.8 times 10 to the 26 meters squared in, what would that be, diameter. So 93 billion light years. Let's see if we can go ahead and add this in. Alright, so this would be 98 billion if I'm correct, or 98 gigalight years. And it decided to turn into a star again. Oh, I see. Let's go ahead and lock the mass again, which keeps turning itself off. And it vanished. It just completely disappeared, which is not completely incorrect of what would happen, but let's go ahead and try this once more. Here we go, I think I got it to work. And it's equivalent to 81 moons, so let's go ahead and correct this mass real quick. Oh, that's weird. So if we don't lock one, the other one messes up. Let's go ahead and paste this value back in. And now we have a super large Earth. If I hit play, it's going to want to shrink and condense very quickly. So I'm just going to avoid doing that. Here is Earth. At the scale of 1.67 million Milky Way, it looks like. In radius. Oh wait, interestingly enough, I did actually put the value in radius, not diameter, so I should probably translate that real quick. So here we go. This should be a little bit more accurate to what the observable universe is. Go ahead and drop in a galaxy orbiting around it, just to get an idea of how small it is. I can't even see Andromeda, but let's go ahead and zoom in. And keep zooming in. And it gets to a state where I can't seem to zoom into the planet anymore, it just kind of makes up the background of the simulation. Or it's because I'm zooming so much. Oh, that is a very odd effect. The layer of the planet seems to always overwrite the galaxy there. But the game accelerates as you zoom in and out, to zoom in and out faster. So to see this object, I am moving significantly faster as I zoom out further like this, than as I am zooming into Andromeda right now. But essentially, a planet like this, of this density, wouldn't even exist. These particles would be so far apart, and this would have such a low density that essentially each particle would probably be pulled away by like other galaxies and stuff like that within it. It would be less dense than something like a interstellar dust cloud. Basically non-existent. You wouldn't even be able to visualize it because the particles would be so far apart. But it's kind of a fun little thought experiment. But I think it would be very quickly torn away by other galaxies and other objects inside of our universe's gravity. Now let's go ahead and go into this little Andromeda galaxy over here. Say little like it's actually small. And look at this black hole. This is the black hole that's in the center of the quote-unquote Andromeda galaxy. The galaxy simulations really aren't quite there yet, but let's go ahead and put the original Earth inside this black hole here. If I could even zoom into it. Ah, there it is. So that's interesting. Let's go ahead and drop the sun in. So there's that crazy large Earth, which I really feel like the perspective here is not really really shown off in great detail, because it looks like it's almost inside of this galaxy, but it's really not. But you can see the sun there next to the giant supermassive black hole that's in the center of Andromeda. Andromeda is only that of a speck compared to the observable universe. And this is only the universe that we can see, where light can reach us. As time progresses, we'll be able to see a little bit more, but there is a limit to what we can see in the observable universe. But that is a fun little concept to mess around with. Anyways, if you guys liked the video, please subscribe, and until next time, I will see you in the next video.